Hey there, how's it going? So in this video, I'm just going to show you the different ways of writing tail recursion, Python and Scala. I'm going to start with Scala first. So say, for example, I have this list of data. I want to add every integer together, return the results. So what I want to do is basically use tail recursion to perform the operation. So what I'll do first is I will define a function called sum data. So this function is going to take in the data list. So it will be of a list type, and it's the data type inside the list is going to be integer, right? And since it's a tail recursion, I'm going to have an accumulator. I'll say the accumulator is going to be of integer. Instead of integer, I'll say big int, and the default value is equal to 0, and the return value is going to be big int. So what I'll do first is basically match the data, which is the list. So I'll say lst match. So I'm going to say case head and tail. Case head and tail. So, and my condition will be if tail dot length is greater than or equal to 0. What I want to do is I'm going to recursively call the function. So I will say sum data. So instead of returning the original list, I will return the tail. So in each iteration, we'll be calling the tail, right? And the accumulator now will be accumulator plus head. You know, in the first iteration, the accumulator is 0 here. So it's going to be adding the accumulator to the whatever the head is in each iteration. So in the first iteration, it's going to be 0 plus 1. In the second iteration, we will return the tail. Then it's going to be the 0 plus 1, then plus 5. Then the third iteration, 0 plus 1 plus 5, that is 6. Third iteration will be 6 plus 3, and so on. If that is not the case, right, I want to return the accumulator. Here I will say case, whatever, right, whatever the case is, anything else, I will return the accumulator state, right? So here it's saying it's recursive. I want tail recursion. This one, if tail is the tail dot length is greater than or equal to 0, I want to recursively call it. Otherwise, else, I will say return the accumulator, and whatever any other cases, we just return the accumulator. So this one is if you hover over this, you see this is still recursive, right? So to make it more apparent, you can use a tail rec, which has to be imported from the annotation. So this is how you write it in Scala. So to confirm the answer, we can go ahead and say print line sum data, be able to get so this is sequence. Okay. So if I run this one, we should be able to get 83. Okay, now you can see the answer is 83. Now let's write the same tail recursion in Python. So I have a Python notebook, right? A Jupyter notebook. If you want to know how to install Jupyter notebook, I've done a tutorial on that. You can check it out. So to do this, I'm going to just paste this one here. So this is going to be, so in the case of Python, I will just use the list like this. So I can define a function called onData. It's going to take in a list and an accumulator. By default, accumulator is equal to 0, and I'll say, so what I want to do is I want to match the data. Then I'll say case head, and so you have to use that as direct tail, head and tail. So case head and tail. Now use the same logic, right? We say if, okay, it's going to take some time to return the answer. I think I'm getting some error. Let me check the code again. Okay, so I think this place has to be LST, right? Instead of getting the data directly. So we have the LST here. So we make use of the LST. And so if we try to run the code again, you can see we get 83, which is the same, result that we got in Scala. So you can easily do this by using foldLeft. So for example, in Scala, we have a built-in function called foldLeft. Say well, some data equal to, so we have to get the data dots foldLeft. So in foldLeft, you have to specify the starting integer, or you have to initiate a value. For example, 0. So you use the 0. So it's kind of going to traverse through the list element, right? It's going to go over the list elements and perform whatever operation you want to perform on those elements. So for example, it starts with 0, then it's going to, what it's going to do first is, if you say use plus operation, right? So it's going to use the first 0, then add it to the first element here, which is 1. Then the next iteration is going to add to the result to the next element, which is 5, and so on. So if we print this one now, let's say print 9, some we should be able to get the same results. You can see we are able to get the same result, right? So now if we go back to Python, right, we built a function called reduce, so we can make use of reduce. So to make use of it, you have to import it from function tools, the Python function tool. So you have to say from tools, imports, reduce. So now you can go ahead and make use of reduce. So you can see so data equal to reduce. So reduce basically takes in a function, a list, and the initial value, right? So for example, in foldLeft, we specify an initial value, which is the 0 here. So we have to specify initial value when we are making use of reduce as well. So if the first thing it takes is a function, so we are going to make use of lambda. And in the case of um, Scala, we can make use of arrow function, or here Python we can make use of a lambda. So we say x, y. We want to basically use a plus operation, so we say x plus y. Then it takes in the list, in this case, the data list. I'll copy it and paste it here. So it takes the data and the initial value is going to be 0. Now I can go ahead and say print some data. So you see we get the same result as well, which is 83. The easier way is just to make use of you can say print some data. So because sum function is a built-in function in Python, so you can just get the results quickly. Yeah, that is it for this video, guys. Thank you for watching. Don't forget to hit the like button, subscribe button, and leave a comment. Have a lovely day and goodbye.